Okay, in this webinar, we are going to discuss about big data, what is big data, different types of big data, and next Hadoop and its components, HDFS and its architecture, and a little bit of introduction to MapReduce. The further details about MapReduce will be discussed and in detail in the upcoming webinar. What is big data? Big data is a collection of large data sets that cannot be processed with, with using traditional computing techniques. It is not a single technique or tool, rather, it involves many areas of business and technology. Like many freshers will not understand what is big data. Many people will think big data as a technology and not as a large data set. What usually comes under big data? Big data involves the data produced by different devices and applications, like the social media data. The social media such as Facebook and Twitter hold information and the views posted by millions of people across the globe. That is big data. Stock exchange data. The stock exchange data holds information about the buy and sell decisions made on a share of different companies made by the customers. That is big data. The power grid data, the transport data, even the search engine data. Search engine retrieves a lot of data from different databases. That is also big data. These all things comes under the umbrella of big data. Next, I would like to explain the difference between data scientists and Hadoop developers. Data science is completely different from data processing. Data science is analyzing the given data set. Data scientists use R, SAS, and other technologies to analyze the given data and to visualize the data, whereas Hadoop is used to process the data, to cleanse the data, to wrangle the data. So many people will get confused that Hadoop comes under data science and everything, but learning Hadoop and the data science languages like R will help. Will actually help. Coming to the different types of big data. Like big data can be in different forms. It can be structured data or semi-structured data or completely unstructured data. Structured data is like the data which will be there in tables, which we call relational data, which we will access using SQL and PL SQL. Semi-structured data is the XML data. Unstructured data is the raw data, which will exist in different formats like Word format, PDF format, text format, media format, and even the logs which are generated from different programs or different executions or different jobs. Like all the logs are also comes under the unstructured data. Through all these things are different forms of big data. We can handle big data using Hadoop framework. What is the main benefit of big data? Why did this become a buzzword these days? Like using the information kept in the social network like Facebook, the marketing agencies are learning about the response for the campaigns, promotions, and other advertising mediums. Like they will analyze the data and understand the people's minds. Okay, next coming to why, Hadoop came into existence? Like what is the problem with the previous traditional enterprise approach? Let us discuss about that now. Like uh, the picture which is being shown now is the traditional enterprise approach which was used in earlier days when Hadoop didn't come into existence. In this approach, an enterprise will have a computer to store and process big data. For storage purpose, the programmers will take the help of the choice of database vendors such as Oracle, IBM, etc. In this approach, the user interacts with the application, which in turn handles the part of a data storage and analysis. But the drawback in this approach is this approach works fine with these applications that process less voluminous data. Whereas when the volume becomes more and more, that the volume of the data that is accommodated by standard database servers becomes more and more, then the processor will have a lot of burden that in processing the data. But when it comes to dealing with huge amounts of scalable data, it is a hectic task to process such data through a single database bottleneck. For that problem, Google solved this problem using an algorithm called MapReduce. This algorithm divides the task into small parts and assigns them to multiple computers and collects the results from them, and then it integrates the entire results and forms the result dataset. That is Google's solution for that problem. Here is the Google solution for that problem. Instead of one computer with a super memory and super RAM doing solving the problem, it is better to split the data set through multiple machines and multiple machines executing the problem and then sending the results to the centralized system and then to the end user. This will solve our purpose. And that is how Hadoop came into existence. Using the solution provided by Google, Duke Cutting and his team developed an open source project called Hadoop. Hadoop runs applications using MapReduce algorithm, where the data is processed in parallel with others. In short, I can say Hadoop is used to develop applications that could perform complete statistical analysis on huge amounts of data. Here, you can see the diagram where the single data set is split into multiple MR tasks. MR means MapReduce tasks, which are again which will further go into the steps like shuffle, sort, and everything, and then the big data is processed, and the end result is combined into one single output and sent back to the user. Like what is Hadoop? Hadoop is an Apache open source framework written in Java that allows distributed processing of large data sets across clusters of computers using simple programming models. The Hadoop framework application works in an environment that provides distributed storage and computation across clusters of computers. Hadoop is designed to scale up from single server to thousands of machines. Like initially, you can start executing a program with just 3 to 4 computers, and again, during the runtime, you can increase the number of machines. Like Hadoop is that much scalable. Coming to the architecture of Hadoop, at its core, Hadoop has two major layers, namely the processing layer and the storage layer. Processing layer, MapReduce comes under the processing layer, and Hadoop Distributed File System, the HDFS, comes under the storage layer. What is MapReduce? MapReduce is a parallel programming model for writing the distributed applications developed at Google for efficient processing of large amounts of data. You can process very large amount of data using MapReduce in a simple way. It the MapReduce framework will itself take care of distributing the data, splitting the data, and sending it to different machines. All these things are taken care by the MapReduce framework itself. What is HDFS? HDFS, Hadoop Distributed File System. The Hadoop Distributed File System is based on the Google File System GFS. It provides a distributed file system that is designed to run on a commodity hardware. Like it has many similarities with existing distributed file systems. However, the differences from the other distributed file systems are significant, very significant. It has a lot of difference. Though it is similar, it has many differences. Like it is completely fault tolerant. Say, for example, if you are executing a MapReduce program on a distributed file on a HDFS Hadoop distributed file system, if suddenly a cluster goes down, a single node in a cluster goes down, then even though the data inside that is replicated and the data will not be lost. Since it is replicated, another copy of data will be used by another node and the data is processed and the end result is sent to the user. So there will not be any loss or damage to our process. And what is Hadoop Common? Hadoop, what are the common utilities and YARN framework? Hadoop Common, these are the Java libraries and utilities required by other Hadoop modules. Like what is Hadoop YARN? Hadoop YARN is a framework for job scheduling and cluster resource management. Like YARN framework was not previously there. It was there after Hadoop version 2.0. From 2.0 it came into existence. Like the MapReduce task, the pick task, the hive task, all these things can be scheduled using an amazing framework called Apache Uzi. Uzi is like Uzi is really amazing. You can actually schedule as many number of jobs you want. Now we will discuss about how Hadoop works and the advantages of using Hadoop. Like how does Hadoop framework work? It is quite expensive to build big servers with heavy configurations that handle large scale processing systems, right? Like if you want to process a very large data set using a single machine, it should have a super memory and it should have a RAM processing. It should have amazing RAM processing system. Like uh, such a kind of system will be really expensive. Instead of that, you can actually use multiple nodes on a cluster. Like you can even connect multiple laptops, the laptops which we use, and form a cluster and process the data using our simple laptops itself. Like that is the main motivational factor behind using Hadoop, that it runs across cluster and low cost machines. Hadoop runs code across cluster of computers. This process includes various tasks, like initially the data is divided into directories and files. The files are divided into uniform sized blocks of 128 MB or N64 MB. These files are then distributed across various cluster nodes for further processing. The HDFS is on top of the local file system of the machines. Every PC will be having its local file system, right? On top of that, there will be a distributed, Hadoop distributed file system, which will be supervising the processing. The blocks are replaced. The blocks are the blocks of memory in which the data is split, are replicated in for handling hardware failures. Certain laptops or certain nodes might fail in between the processing stage, right? So to avoid such a situation, the blocks are replicated to handle those situations. Like and again, the Hadoop framework will take care whether the code was executed successfully or not. Like it is such fault tolerant. Like it will perform a sort stage in between map and reduce stages, and it sends the sorted data to a certain computer, and finally it writes the debugging logs for each job executes. Next, coming to the advantages of using Hadoop. One second, let me just check out whether you have any doubts so far. Okay, moving forward, what are the advantages of Hadoop? Hadoop framework allows the user to quickly write and test distributed systems. It is efficient and it automatically distributes the data and work across the machine, and in turn, it utilizes the underlying parallelism of the CPU cores. The CPU cores are meant for parallelism purpose. These days, we are using octa-core systems usually in laptops, right? But Hadoop makes the best use of both. Hadoop does not rely on hardware to provide fault tolerance and high availability. Rather, Hadoop library itself has been designed to detect and handle failures at the application layer. Servers can be added or removed from the cluster dynamically. In between the execution, also you can remove a server, or you can increase a node. Hadoop continues to operate without interruption. Another big advantage of Hadoop is that apart from being open source, it is compatible on all platforms since it is Java based. Okay, we will discuss about the Hadoop environment setup, and how to multi-node cluster setup and a single node cluster setup, and how to execute this MapReduce frameworks in the upcoming webinar. And now we will come to what is the details of HDFS. Hadoop distributed file system was developed using the distributed file system design. It is it runs on the commodity hardware. Unlike other distributed systems, HDFS is it is really fault tolerant and designed using low cost hardware. Like the what coming to the features of HDFS, it is suitable for distributed storage and processing. Hadoop provides a command interface to interact with the HDFS. The built-in servers of name node and data node. I will explain name node and data node in the next slides. Help users to easily check the status of clusters. You can access the streaming to the file system, and HDFS provides file system permissions and authentication also. Coming to the HDFS architecture, you can see the HDFS architecture here. You can see many parts like the name node, data node, client, and the replication. Like we will discuss all these things now. Like what is the name node? The name node is the commodity hardware that contains the GNU Linux operating system. It is just one PC which is having the GNU Linux operating system and the name node software. It is a software that can run on commodity hardware. The systems having the name node acts as a master server. It is a master slave concept, right? So the name node acts as the master and the data node acts as a slave. The main that the main tasks of the name node are: it manages the system namespace, it regulates clients' access to files, it executes file system operations such as renaming the file, closing and opening the files and directories, etc. Next, coming to the data node. The data node is a commodity hardware having the GNU. It is also having the GNU Linux operating system, and every node in the cluster there will be data node. These nodes manage the data storage in their system. Data nodes perform read-write operations on the file system as per the client request. Whatever clients request, first the request goes to the name node, and the name node will actually contact with the data nodes, and then the process is done. Like the instruction is executed. Suppose the client wants to rename a file, then the name node will actually change the name of the file. Next, okay. Coming to the MapReduce part, which is the most important part to handle the data. Like using the MapReduce only, we will handle the data. How do- The MapReduce framework is used uh, to write applications to process huge amounts of data in parallel on large clusters of commodity hardware in a reliable manner. MapReduce is the processing technique and a program model for distributed computing based on Java. The MapReduce algorithm contains two important tasks: the map task and the reduce task. The map task and the reduce task. The map task takes a set of data and converts into another set of data where the individual elements are broken down into tuples. Like in the MapReduce framework, we will handle only key value pairs. Everything will be a key value pair. In the reduce task, which takes the output, it usually takes the output of the map task as the input to itself and combines those data tuples into a smaller set of tuples as the sequence of the name MapReduce implies. The reduce task is always performed after the map job. Like it takes the output from the map task as the input to itself. Okay, coming to the job tracker and task tracker. The job tracker schedules the jobs and tracks the assigned jobs to task tracker. The job tracker takes care whether the task tracker is executing the jobs or not. The task tracker, what does the task tracker do then? The task tracker reports the status to the job tracker. What is a job actually? A job is a program which is a combination of map task and reduce task. The map, a job can be only map task also sometimes. In the next webinar, we will discuss. The next webinar is scheduled on 16th May, which is Saturday 7 p.m. Like in that, we will discuss how to set up a single node cluster and a multi-node cluster. And we will also run some sample MapReduce programs with using a very large data set, and we will convert it into an efficient program. And we will also discuss about chain mappers. In the next video, in the next webinar, like it is scheduled on 17th May, and in that we will discuss the important concepts of pig and hive, which are very important means, which are really efficient when you compare with the MapReduce program, which is written in Java. Like the pig takes care of converting it into an efficient program. The pig takes care of its program by itself. It will convert it. It will convert it into an efficient program. The framework will take care for it. Thank you. If you have any doubts, please write them to me. Like here is my email ID. You can write them. You can write all your doubts to me anytime. Like here is my LinkedIn profile, and here is my website srirampilipper.com. You can view them. You can view all the posts regarding Hadoop or Java. You can write You can write all your doubts to me. Thank you. Thank you very much for your participation in this webinar. I hope to see you all in my next webinar also. Have a nice week. Thank you.